All right, so we're going to look at geometric mean as my children are screaming in the background. So we're going to look at geometric mean just in an algebra sense right now, not tying it into our right triangles yet, because we're going to actually use geometric mean when we talk about the altitude of a right triangle and one of the three altitudes. But right now we're just going to look at it as plain vanilla geometric mean. Now what a geometric mean is, it's a value that we can use that between two different numbers is the denominator of one fraction and the numerator, the denominator in a fraction with one number and the numerator in the fraction for another number, but that creates equal ratios. So for example, that might be kind of hard to understand. If I want to find the geometric mean, okay, so if I want to find the geometric mean of A and B, what I'm going to do is I'm going to create a proportion with that. So what number, what value, and my geometric mean, I'm going to call that X. What value could X be so that I can set up X as the numerator of one fraction and the denominator of the other and create two equal ratios? Now, you can say X over A equals B over X, or you could, if you want to, say X over B equals A over X. Either way, this X, this is your geometric mean. It is going to be diagonal. It's going to be the numerator with one of your values and the denominator with the other. So how do we solve proportions? We cross multiply. Some people get confused because they think that you have to have a specific location for A and B. They're interchangeable as long as the geometric mean value, the variable you have representing the mean, is here. So if I were to cross multiply, X times X is X squared, and A times B is AB. Okay? Now, over here I switched it, right? Well, let's cross multiply here, and look what happens. What's X times X? X squared. A times B is AB. So either way, as long as the geometric mean is positioned as the numerator of one and the denominator of the other, using the two values you're given, you'll find the correct answer. And then how do we solve for X? Well, when we solve for X, we take the square root. So what I'm going to do, I have X squared, I just want X. I'm going to square root both sides. So X is going to equal the square root of A times B, and over here you'll get the same thing. X equals the square root of A times B. Okay? So basically, what this is going to show us, the geometric mean is going to be the square root of the product of the two values you're given. Now, in my classes, I'm not necessarily going to show that shortcut as a primary way to do it because I like setting up proportions and I like being able to work through proportions because proportions help us solve so many different types of questions and types of problems. So let's try an easy one. Let's try number one. Okay? And let me move over here a little bit so you can see it. So number one, I want to find the geometric mean of 1 and 4. So what would be the geometric mean of 1 and 4? So that would mean that I'm always going to call the geometric mean X just because I want to. I can do whatever I want. So I'm going to set it up 1 over X equals X over 4. What number can be placed under this one and above that one and create two equal fractions, two equal ratios, which is what a proportion is. A proportion is two equal ratios. That's what a fraction is. So I'm now going to cross multiply. So I have X times X, which is X squared, and I have 4 times 1, which is 4. And then I'm going to take the square root of both sides to solve for X, because I have X squared, but I want X, so X equals 2. Now, if you want to get really technical, you could say positive or negative 2, but for our purposes right now, we're going to say only positive 2, because what we're going to end up doing ultimately is we're going to use this geometric mean as an altitude or the length of a triangle, the length of a side of a triangle or the length of an altitude, and length is not negative. So we're going to use the positive. Now you could have also done x over 1 equals 4 over x, like I showed you up here. You could have done it both ways and you would have gotten the same thing. So let's check our answer. Does 1 over 2, if I plug the x in, if I plug in 2 there and I plug in 2 there, does 1 over 2 give me the same fraction and the same relationship as 2 over 4? And the answer is yes, because what does 2 over 4 reduce to? 1/2. So 1/2 equals 1/2. That is a good ratio. That means that 2 is in fact the geometric mean of 1 and 4. So let's try another one. So let me scoot this up a little bit. So right here, make sure I'm on the screen. We've got number 2. Okay, so let's try a second one. The geometric mean is not necessarily always going to be a whole number when you're looking at lengths of triangles. But for our purposes here, most of the time they are going to be whole numbers for what we're using them for at this current moment. So let's say I want to find the geometric mean of, let's see here, I'm trying to think of something we can do. Let's find the geometric mean of 5 and 125. Let's do a bigger number, okay? So I've got 5 and 125. So let's see what we can do about the geometric mean here. So that means 5 over x equals x over 125. So I'm trying to figure out what the geometric mean of these guys are. So what I'm going to do is I'm going to cross multiply. So I have x squared. I'm going to cross multiply here. I've got 500. I've got 625. Okay, 625, because that's 5 times 125. And then I have x squared equals 625, but I don't want x squared. I just want x. So I'm going to take the square root of both sides, and x is going to equal 25. So according to my calculations, the geometric mean is 25. So what that means is if I take 25 and plug it in here, and I take 25 and plug it in here, 5 over 25 should give me the same ratio and the same relationship as 25 over 125. And the way we check that is we reduce. 5 and 25 have a greatest common factor of 5, okay? So 5 goes into 5 one time, and 25 5 times. So I've reduced that. Now I want to reduce this one. Well, these two have a greatest common factor of 25. 25 goes into 25 one time, and then into 25 5 times. So are these ratios equal? Yes, they are, which means 25 is your geometric mean. So that's how you find geometric mean using simple algebra and proportions when we're not looking at it in regards to a right triangle or the altitudes of a right triangle, which creates our similar triangles, which we will do in the next lesson.